complexity analysis in terms of computer programming. Complexity of an algorithm is usually defined as the time taken by the algorithm and the memory consumed by the algorithm. So, what is a good algorithm? Uh, a good algorithm is an algorithm which consumes less time and less memory. But this time and memory terms are very abstract terms, or you can say these are very relative concept, because the time uh, of an algorithms may change depending upon the hardware we are using. Like the older machines can take more time than the new faster machines. Similarly, operating systems and languages, the high level languages usually take more time to compute the same operations as compared to the low level languages and compilers etc. So for now we will not take into account these factors, because these factors are variables and are not constant, so we cannot compute complexity of any algorithm. If we take into account these factors, we will ignore these factors altogether, and what we will account will be just the number of steps or the number of operations that an algorithm performs. And the number of operations means uh, simple arithmetic operations like plus, minus, multiplication, division. Comparative operations are the array operations. So we will only count those fundamental operations in the given algorithm, and on the basis of that count we will compute the complexity of the algorithm. So let's say here is a simple piece of code and we have to count its complexity. If we analyze this piece of code, we see that this statement, that is the initialization statement, it will be executed only once. Similarly, this turn statement will be executed only once, and in the same way this statement of the loop, which initializes the variable I with 0, will also be executed only once. So these three statements will be executed only once. We have these three operations, plus there are 5 other operations like this, this, and this, and these 5 operations depend upon the value of n, or you can say the value that will be given by the user. So the complexity of this piece of code will be 5 into n. N is the number of time the loop will execute, plus 3 constant operations. So by computing this way, we can say that the complexity of this piece of code is 5n plus n. So if the value of n is 10, it will take 53 steps and are 53 operations. If value of n is 100, it will perform 503 operations. Similarly, 5003 operations for in case of n is equal to 1000, and so on. And here is another very important concept that is called asymptotic behavior. And in asymptotic behavior, what we do, we ignore the constant values and we only take into account the variable factors. So this is very important concept, and to understand this concept you can say, have a simple example, like if you go to a shop and you buy a candy that is only 2 cents price, you will pay 2 cents to the shopkeeper, and you will take that candy of a candy. So in this case, these 2 cents are important and countable. Now take another scenario. Say you are going to purchase a very big plaza and other property worth $1 billion. So in this scenario, you will ignore 2 cents. Like if someone says the price of the plaza and all other property is $1 billion and 2 cents, that will be very funny statement. So two cents are quite irrelevant in this scenario where the price is $1 billion. So this is the main concept, it means when in a given statement, in the given equation, one factor increases to such an extent that the other constant values can be ignored. It's called asymptotic behavior. Like I say, suppose in an above scenario, 5n plus 3. If this statement take the value of, like say, if 5n becomes like this, then this 3 becomes irrelevant. So it means we can ignore the constants 3 in this scenario, which we are going to add. Similarly, we can also ignore the constant 5, like if we say like in case of 5 into infinity is equal to infinity. So when n takes huge value, then all the constants, whether they are being multiplied or they are giving added, they will be ignored, and the complexity will be only n. So this is asymptotic behavior. So in this complexity computation process, we will ignore all the constants, because whatever the value these constants have, at the end of the day they do not matter, because they are fixed and we know them in advance. The important and the risky factors are the variables, like here n, because we do not their value in advance and user can give any input. So we will only count those invisible threats which are which we cannot you can say predict in advance. So unpredictable factors are counted for computing the complexity, and this is called asymptotic behavior, where the constant lose their value as n grows. So with the growth of n, we will ignoring all the constants. So now let's see some examples of complexity. So this is a very simple example where we do not have any loop and any invisible or inflatable variable. So these three statements will be executed only one time. So the complexity of this piece of code is O(n). So in short, any piece of code where you can count the operations in advance have complexity equal to 1. So this is the rule of thumb. So by this rule of thumb, let's check the complexity of the next code. Here you have a loop, but you can count the iteration of this loop because it doesn't depend upon the user's input. Rather, here the value is constant, that is 10. So the complexity of this loop is again 1. Next, another loop, but here this loop really depends upon the user's input, and so that is n. So the complexity of this loop is n. And the next we have two loops, nested loops. So you know, in case of nested loop, if inner loop iterates 5 times and the outer loop iterates 10 times, total iteration would be 50. So you know, in case of nested loops, the iterations are multiplied. So there, and in the same way, their complexity is also multiplied. So n complexity for this loop and n complexity for this loop. So the complexity will be n into n, that is n raised to power 2. Similarly, here we have 3 loops, three nested loops. So the complexity will be n raised to power 3. And similarly, if we have 4 loops, complexity will be n raised to power 4. And now we see another interesting scenarios. Say you have a program which have all these loops. So this is a complete program and you have to compute the complexity of this whole program. So what would be the complexity? You may easily say that the complexity of the program would be n raised to power 3 plus n raised to power 2 plus n plus 1. So no, here is another important or interesting thing. In case of this scenario, like this situation, we will only count the highest complexity piece of code and we will ignore other low order complexities. So the complexity of this program will be f raised to power n raised to power 3 n cube. So this is also a rule which say we will only go for the maximum complexity in a given program, and will not add up other low level complexities. And now we see another piece of code here. You can say you guess what would be the complexity, and here say if x is 416, then next iteration x will become 8, then x will become 4, and so on, and this loop will execute 4 times. And in case of x is equal to 8, this loop will execute 3 times. If x is equal to 4, this loop will execute 2 times. So here you are seeing a pattern, which pattern says the number of iteration depend upon the log of the n. If n is 16, iteration will be 4. In case of n is equal to 8, we will have 3 iterations, and so on. So for this piece of code, the complexity is log n. And similarly, this piece of code also has log n complexity. And finally, we have, and this piece of code has n log n complexity because this loop execute n times and it has log n complexity inside it, so both complexities will be multiplied with each other, so complexity is n log n. And finally, here is another piece of code that is a recursive code of Tower of Hanoi problem, and complexity of this code is 2 raised to power n, because if it grows this way, that if n is 2, it will have 4 iterations, and if n is equal to 4, it will have 16 steps. So it grows this way, so we have complexity 2 raised to power n. So this is the basic and a short introduction of complexity analysis, and in the next lecture we will see what is big O, big theta, small theta, big omega, small omega, and tight bound and loose bound. So stay tuned and watch the next lecture as well.